Japan's air force was more than enough to deter an attack from China or Russia. However, Japanese authorities have recently become concerned that those militaries have surpassed their airborne capabilities. Yet not relenting in their quest, the result is nearly here: Japan's Godzilla F-X Stealth Fighter. Although superpowers have increasingly probed Japanese airspace, measuring Japan's ability to respond to an airborne threat and alarming Japanese defense agencies. Despite this threat, Japan has taken several steps to ensure its defense and security settings react to the environment around it. How have they been able to do this? Join us as we explore Japan's Godzilla F-X Stealth Fighter that is nearly here, and how it can destroy China in 30 seconds. From its inception in the early 2000s, the F-X program aimed to research what the sixth-generation combat aircraft would look like and what it would take to develop a fleet of warplanes with such characteristics. Japan knew that if it wanted to produce a fighter capable of facing current Chinese and Russian aircraft, but also providing protection against future iterations, it needed to skip an entire generation. Between December 2029 and August 2010, the Japanese Ministry of Defense thoroughly studied current and future trends regarding combat aircraft technology. The research results helped the Japanese develop the concept for a sixth-generation fighter codenamed I-3 Fighter for informed, intelligent, and instantaneous. However, if it was to be considered a sixth-generation design, the new fighter needed to have a series of specific features, including advanced radar systems to counter the stealth technology of other fighters, receiving targeting information from other platforms like drones, fighters, and airborne early warning and control aircraft, the use of flyby optics to process data even faster, stealth technology, gallium nitride semiconductors to boost radar performance, and a new, more powerful engine. The Japan Air Self-Defense Force, JASDF, has been operating the Mitsubishi F-2, which has been a very weighted and multi-role fighter since the year 2000. This fighter was initially locally produced, with 98 examples released between 1925 and 2011. Although the design was a modified form of the excellent general dynamics of the now-locked F-16, the Fighting Falcon, an advanced, all-modern replacement to contend with the growing threats originating from North Korea, Russia, and most importantly, China, brought about the F-X Next-Generation Fighter Initiative. Mitsubishi Heavy Industries was tasked with the project and continued supporting the development until the last stage. Initially, the JASDF ought to procure the advanced Lockheed F-22 Raptor 5th Generation Air Superiority Fighter until its purchase was banned from being exported in the year 1997 by the American government based on the idea that the technology might be too sensitive for humans at large. This led Japan to seek another foreign solution or settle on local development. There can be a blessing in denial because Japan chose the latter and decided on local development. The decision, however, eventually brought about international collaboration. Therefore, the F-X program owes its existence to the I-3 Fighter project and the X-2 Shinshin Technology Demonstrator program. The X-2 became a flyable, one-off prototype exhibiting some of the qualities of the F-X, most notably its stealth. Based on research and feedback from the Shinshin X-2, the Japanese Ministry of Defense began the early development of the Mitsubishi F-X in 2020. The current concept describes a twin-engine stealth fighter designed for air superiority. It is planned to be considerably more significant than the F-22, which has earned it the Godzilla nickname. The increased dimensions give the aircraft an extraordinarily long range and large ordnance capacity. In addition, Defense Minister Taro Kono has stated that they are focusing on developing unparalleled network capabilities and the ability to carry more missiles than the F-35. Several exterior designs have been proposed, adjusted, and tested via 3D modeling and specialized virtual simulation software, and the design prioritizes speed, agility, and stealth. The F-X will replace conventional hydraulic systems with electric actuators to give the designers much more freedom when creating their bodies without being limited by the internal hydraulic systems. The aircraft will also use state-of-the-art adhesive molding instead of conventional fasteners to achieve formidable integrity at a much lower weight. This will also reduce the person-hours needed to deploy the novel aircraft. The F-X fighter engines incorporate three-dimensional thrust vector nozzles, allowing the aircraft to achieve high maneuverability and improve stealth capabilities. The current form of the F-X relies on a pair of embedded afterburner turbofan engines to achieve the required overrange performance and overall survivability. This will facilitate a sizable airframe that is also designed to house the fuel reserves needed for extended surface warfare and radars mounted next to internal weapons. Also, the electric actuators will replace age-old hydraulic methods, and stealth features will be heavily incorporated into the design to reduce radar cross-section and deflection. This is achieved through unique materials and airborne systems. Composites will become part of the fighter structure, reducing weight while improving performance range. The engine of choice is an IHI XF91 afterburner turbofan, which is estimated to produce 22,000 pounds of dry thrust and up to 30,000 pounds of reheated thrust. The turbofan is designed to be particularly narrow to maximize the internal volume of the airframe, which can accommodate more weapons, fuel, and other related systems. The exhaust ports are closed by thrust vectoring flaps, giving the F-X exceptional agility while optimizing its stealth qualities. Two of these engines will be installed in the design, giving the fighter excellent performance, but at the cost of greater maintenance and repair obligations as well as increased fuel consumption. Looking at the armament, an array of sensors to engage enemy stealth aircraft is included, such as an active electronically scanned array radar, a passive radio frequency sensor, and an infrared camera. These sensors use gallium nitride to improve their performance against low radar cross-section targets. The F-X also has an RF self-defense system that instantly and globally disrupts radio waves to prevent being hit by incoming projectiles. Another feature is a helmet-mounted display with a wide field of vision, binoculars, multicolor displays, voice recognition, and 3D sound capabilities. Serpentine air ducts, an internal weapons bay, electromagnetic wave absorbers, and metamaterials give the F-X its stealth capabilities, drastically reducing its radar cross-section. Additionally, a plasma stealth antenna system deflects radio waves, and the technology creates a temporary plasma burst to deflect incoming radio waves. Apart from conventional weapons and warheads, the F-X can be armed with a microwave cannon to disrupt incoming missiles. It can also deploy combat support unmanned aircraft drones capable of functioning as loyal wingmen to the fighter. The drones help identify targets, fire munitions, and direct incoming missiles away. However, the Mitsubishi Electric F-X company is a family that continues to be successful as a customizable compact control solutions provider, allowing customers to choose the best model for their applications. The control systems require minimal setup and keep program development time short for ease of use. Hence, a high performance-to-cost ratio makes economical design solutions for a diverse range of applications a reality. These features, combined with Mitsubishi Electric's legacy in quality and reliability, ensure that the third generation of microcontrollers will continue to be at the forefront of the compact market and provide customers with a leading edge. The F-X is the original dual system bus, a high-speed, fully expandable compact designed to seamlessly control communication, networking, analog, and positioning systems. With a maximum of 384 controllable local and networked I/O via CC-Link, the F-X uses its power and flexibility to provide a solution for various applications. The F-X is equipped with a third-generation compact power line communication, PLC, which works efficiently with more speed, performance, memory, and new functions alongside built-in high-speed processing and positioning. The F-X can control a maximum of 256 connected I/O and up to 384 points with CC-Link remote I/O. Keeping it simple, The FX is the fit-and-forget power line communication (PLC) solution for space and cost-conscious applications requiring up to 30 I/O. This minimum expandability, batteryless, maintenance-free controller is perfect for handling straightforward processes and can be hidden away in locations without regular maintenance activities. Having a basic controller for general applications and a high performance with minimal size, superior built-in functionality, and straightforward usability, the FX meets the needs of a variety of user applications. This includes but is not limited to how the FX control system demonstrates the key attributes that form the basis of automation control. Similarly, the FX are equipped with built-in open collector high-speed counters that run between 60 kHz and up to 100 kHz. These high-speed inputs are connected to external devices such as encoders and ultrasound sensors for system feedback control. The FX central unit can be expanded with high-speed input special adapters, enabling differential line receiver inputs up to 200 kHz. The inverter control, also known as variable frequency drives or VFDs, plays a vital role in many conveyors, pumping, and positioning of the systems. While the output frequency of the inverter can be varied easily using analog outputs on any of the FX transfer of both parameters and commands between the company and Mitsubishi inverters can be handled in FX series through serial communication using freak-roll protocol. Each RS-485 interface on an FX PLC can control up to 8 inverters with a total network extension of up to 500 meters when using the FX3 U484 ADP-MB. The built-in high-speed pulse outputs on all transistor-type FX series and special positioning operations instructions are designed to satisfy simple independent axis positioning applications using servo and stepping motors with speed and precision. For more advanced applications like 4-axis control and noise-free interpolation, the FX system can be expanded with special adapters and special function blocks. With high performance at a low cost, the FX series positioning possibilities provide a formidable package. The FX also has upgraded built-in positioning instructions for easier use. It works as an easy step-by-step positioning program using the DTBL instruction. The FX series allows for up to 3 axes of independent positioning control at up to 100 kHz. Similarly, the FX connects 2 high-speed output special adapters to the FX, which provides for up to 4 axes of control at up to 200. Again, with its open field networks for inter-system data transfer and remote I/O handling, a CC-Link enables the update of word and bit devices refreshed at up to 10 megabits per second. With CC-Link-based I/O, the 256 I/O control limit of the FX goes up to 384, and with CC-Link VAR, 2.00 expanded cyclic transmission can also be performed, enabling the establishment of more link points. Programming via CC-Link is also a new feature of the FX. A user connected to the master FX PLC programming port can access all connected intelligent device station FX PLCs from one location, saving time and money. In addition, serial communication has long been the established connection method for related systems and data transfer with external equipment and third-party devices. The serial communication allows the FX series to connect efficiently and reliably with other PLCs, sensors, printers, and modems. Multi-drop networks, non-protocol communication, and remote maintenance are just some of the many uses. Networks and remote connections go hand in hand. In the information age, Ethernet has become the personal, commercial, and industrial standard for easy and efficient data transfer. Whether it is between multiple PLC systems or PLC and PC servers, industrial users dictate foremost that data must always be consistent, even in high-noise environments. The FX series uses industrial Ethernet on up to 8 ports, with features such as PLC to PLC communication, extensive email send, receive options, and program upload-download. Additionally, its data management helps keep records of components, key processes, and events crucial for maintaining a reliable system. FX PLCs offer multiple methods for saving data depending on user needs. It can also write data to a CF card in the FX3U CF ADP for the FX3U and FX3UC. In addition, periodic or event-based data can also be logged in 64 files with user-defined names in universal CSV format. Timestamps can also be activated to tag data, allowing easy automatic analysis of trends. Moreover, to provide ease of operation to a system, the overall look and feel of the interface is key. The Graphical Operation Terminal GOT1000 series HMI offers colorful and sharp touchscreen displays that make interacting with the system straightforward. Display modules are also available if only a simple text display is needed for simple monitoring and device settings. The expansion boards, also called BDs, are a basic CPU function extension. Thanks to their compact dimensions, no additional installation space is required. Programming is done directly via the PLC's special commands and a dedicated data register. Serial communication, analog, and digital I/O BDs are also available. Another is the special adapters, also called ADPs, which add standard high-speed functions to the PLC. It is mounted on the left side. These units are extremely compact and easy to use. The programming is similar to the BDs via special instructions and dedicated data registers in the PLC. Various serial communication, analog, temperature input, positioning, high-speed counting, and data logging ADPs are available. Compared to the BDs, the ADPs offer more flexibility and performance. The special function blocks, also called SFBs, are the most advanced function extensions available for the FX PLC. Programming is straightforward thanks to the standardized communication via memory integrated into the SFBs. The integrated CPU performs PLC scan time independently and is perfectly fitted for networking or positioning tasks, thus reducing the load on the PLC main unit. Up to 8 different units can be connected to the main unit. Analog, serial communication, networking, positioning, high-speed counting, and temperature control are available. Compared to the ADPs, the SFBs offer higher functionality and more flexibility. Dedicated SFBs for the FX3GC and FX3UC are available as well. I/O extensions, digital I/O extensions are available with or without a power supply. A wide range from 8 to 38 I/O points with different inputs and outputs are available. There is no limitation on the number of extension units or blocks. You can design the system to match application requirements and check the system power supply and number of available I/O points. Dedicated I/O blocks for the FX3GC and FX3UC are available as well. Moreover, looking at this new fighter's capabilities, Japan announced in December 2023 that it would jointly develop its next-generation fighter jet with the UK and Italy to expand defense cooperation beyond its traditional ally, the United States. Therefore, the Mitsubishi FX fighter jet is targeted to replace the aging fleet of F-2s that Japan previously developed with the United States. The nations will merge their plans for developing next-generation planes. The FX and Britain's Tempest, a successor to the Eurofighter Typhoon, to produce the new combat aircraft for deployment in 2035. The deal will support Japan in countering China's growing assertiveness and allow Britain a more significant presence in the Indo-Pacific region. Japan may have decided to choose Britain's BAE Systems as a collaborative partner over Lockheed Martin, probably because the developmental timeframes of the FX and Tempest programs aligned. Furthermore, FX and Tempest share the same schedule, facilitating collaboration between Japan, Britain, and Italy. Meanwhile, the FX fighter jet is expected to replace the Japan Air Self-Defense Forces, JASDF's, existing fleet of 91 MHI F-2 multi-role fighter aircraft by 2035, while on the European side, the Tempest is being developed as part of the Future Combat Air System, FCAS, which includes plans to work with a fleet of unmanned aerial vehicles, UAVs. The program is undertaken by 4 primary industry partners: BAE Systems, Leonardo, Rolls-Royce, and MBDA. BAE Systems is heading up development for the UK, with Leonardo for Italy. Similarly, the three nations share common tactical requirements for the future fighter. To ensure air superiority as maritime nations, both Japan and the United Kingdom plan to acquire a large multi-role stealth fighter with a long cruising range and twin engines with excellent missile loading capacity at lower costs and more efficiently. In addition, Japan, the UK, and Italy, which are virtually middle powers, can reduce development costs and technological risks by working together. The cost of developing new fighter planes is so huge that it can hardly be covered by a single country alone. In Europe, apart from the Tempest, 3 European countries, namely France, Germany, and Spain, are already jointly developing the new generation fighter, NGF, that sits at the core of the wider Franco-German-Spanish Future Combat Air System, FCAS and SCAF project. For this reason, Britain singled out Japan as a partner in East Asia, going beyond European borders. The UK may think of Japan as being well-funded. However, the United States and Lockheed's refusal to share confidential technological information, such as the source code, has made Japan look to Britain for joint development. Japan is seeking access to the new fighter's source code to allow the JSDF to introduce independent and localized upgrades. Without such access, the JSDF cannot freely introduce its desired modifications, a bitter lesson for Japan that has affected its F-2s and F-15s. By contrast, the UK offered to cooperate in joint research and basic design of the engine and radar, both areas where Japan had been restricted during the development of the F-2. For this reason, there have been high expectations within Japan's Ministry of Defense that Japan could become an equal partner with Britain, unlike the United States. The first FX prototype is expected to complete the construction phase this year, 2024, with a maiden flight expected sometime in 2028. Full-rate serial production will ramp up in 2031, and the Japan Air Self-Defense Force is expected to enter service with the fighter in 2035. More impressively, it will launch Japan into the global weapons development market, cementing it as a military manufacturing superpower. However, the FX Godzilla may deliver just a fraction of what it promised. If it falls short, will it still have the potential to give the Japanese armed forces a formidable warplane far superior to anything in the skies today? We cannot respond to that yet, but we are hopeful that FX Godzilla will become a reality soon. Thanks for watching. While you're still here, click on the link on your screen to watch another of our interesting videos. See you there.